Now let us see some alphabets. Here we have A, H, I, M, O, T, Y, U, V, W and X. And let's check out the symmetry for these alphabets. Now if I am going to divide it horizontally, then what happens is that the upper and lower portions are going to be different. So here if I am going to divide it like this, the shape here and here is different. But here they are same. There are some alphabets which can be divided both horizontally as well as vertically. But first let us consider the vertical symmetry, that is the vertical division. Now if I am dividing this A into two parts, I find that the portion on the left and right are identical. Same way for H, we see that the portion that we are getting on either side are identical. For I also we are going to get the same property, that is whatever is on the left, the same thing we will be getting on right. So these type of division, when we get identical portions on left and right, is known as reflectional symmetry. So here we can divide M in this manner, we can divide O in this manner, T can be divided similarly and Y can be divided here. If I divide U, then I will get two arcs which are exactly of the same shape and size. If I am going to divide V from here, then what happens? I am going to get two lines which are identical and the slant and height and width, everything will be same. In case of W also you will find, and in X also you will find that whatever is on the left and right, they are identical portion, or in other words they are going to be similar, they exactly coincide to each other with the help of these lines. So in all these alphabets, the division, if you note, has been through a vertical line. So we can say that all these alphabets that we have written here, and we have seen the division, that they are all symmetrical with respect to the vertical axis or the vertical line. Now let us consider some other alphabets and see if we can divide it symmetrically in terms of the horizontal line or not. Now let us try to understand symmetry with respect to the horizontal mirror. Earlier we saw the vertical mirror where we were dividing the alphabets vertically. Now if we divide it horizontally, that means like this, let us find out whether these alphabets are symmetrical. We find that these alphabets B, C, D, E and I, whatever portion is on the upper portion of the line, the same portion is repeated here and they are identical in shape and size. So they are actually congruent. In C also we find the identical, D also we find that the portions are identical, E and I, all we find that whatever is on the upper portion of the line, the same we are going to get on the lower portion of this mirror. So if these type of alphabets are called symmetric with respect to the horizontal line or the horizontal mirror. Here we have another two examples, O and X, which can also be divided equally with the help of the horizontal mirror or the horizontal line. So we can divide like this, we get two identical portions up and below. Now there are some alphabets I have written here. These are O, X, I and H. Now these are very special alphabets because they have symmetry both with respect to the horizontal mirror as well as with the help of vertical mirror. So if I am going to divide this horizontally, we see that O is divided into two equal parts, X also similar, I and H, all of them have got two equal portions. But I can also divide these alphabets in terms of the vertical mirror. That means O will have both symmetry horizontal as well as the vertical. So we have two axes of symmetry here. X also similarly can be divided with the help of a vertical mirror. I can also be divided in the same manner, and similarly for H. So these are alphabets which have two axes of symmetry, both horizontal and vertical. But in this case we saw that these alphabets are having horizontal. Of course there are some common here. So O, X and I, which we have written here, have got both. But if you see B, C, D and E, they have only horizontal, and we saw some alphabets earlier where it is having only vertical. So with the help of this line from the center, and if the line is able to divide the alphabet into two identical portions, then we can say that it has got an axis of symmetry. So we will have either one symmetry here as in these, or in this we have two, and there may be alphabets where the axis of symmetry does not exist.